Hi guys, so this is our third science lesson on forces, and today we're going to be thinking about the directions in which forces can act. So a recap of what we talked about last lesson, the Earth and the Moon both have a gravitational pull, which means that all things stay on Earth and don't float off because of this force. Gravity is a non-contact force which pulls us towards the centre of the planet. It's like there's a big magnet in the middle of the planet which pulls us towards it. And we said that the gravity on the Moon is very low compared to the gravity on Earth, so it's only about 17%. And that the size of the force of gravity depends on the object. So if an object is smaller or lighter, it will have less gravity, and if an object is larger, it will have more gravity. So what stops us being sucked into the centre of the Earth? So there's this pull coming from the core. Why do we not get pulled right in to the centre of the Earth? Have a think about that for a second. The reason for it is that gravity is actually a relatively weak force, which is much weaker than the forces that hold together the ground or the floor that we stand on. So it is not strong enough to pull us through to its centre. Gravity is not strong enough to pull us through because the ground of the Earth is stronger. The ground provides what we would call an equal and opposite balancing force to our weight. Because the separate forces are in balance, we do not fall through the ground. So gravity pulls us down, but going in the opposite direction is the balancing force, which is the Earth, which stops us from being pulled through. However, if what we stand on is not strong enough to hold us, for example, a thin layer of ice, a rotten floorboard, then our weight will overcome the support that the floor can provide and we fall through. And when this happens, the forces are not balanced. So the pull of gravity, because of our weight, is stronger in that situation than the force of the ground. So they are no longer balanced. If you have a look around you, have a look around now in the room that you're in. What things can you see which are not directly on the ground? And can you explain why are those things not being pulled down to the ground? Okay, hopefully you've seen a few things. You might see, for example, your lamp balancing on a table. Maybe you can see a glass balancing on the kitchen side. Okay, and these things are not being pulled through down to the Earth. The reason is that while the objects are pushing down on the table, the bookcase, the kitchen shelf, because they're being pulled down by gravity, the items of furniture are providing support or resistance, and we say it's like they're pushing back. And because the forces are balanced, the objects do not move. So when you look at the lamp, gravity is pulling it down, and that's a force which is going downwards, pulling them down. But the table that it's on is pushing back again and giving support so that they are balanced. Neither of them are moving. If a force is balanced, the object is not moving. So if we look at these pictures, if you look at the one on the right to start with, you can see two different forces going on here. Firstly, there's a chair which is being pulled down by gravity and the weight of the chair, and the floor is providing support or resistance and pushing back again. So it means that the chair is not falling through the floor, and as a result, the forces are balanced. Similarly, further to the right, you can see the lantern is being pulled down by the gravity weight of the lantern, but the table is providing a support force. It's providing resistance against the gravity and the weight, and now the forces are balanced. Nothing is moving. On the left, we have a similar type of balanced force where the gravity weight of an object pulls it down in water, but we have a force which is called buoyancy or upthrust or lift, which exerts itself in liquid or gas, which pushes this object back up again. And again, they are balanced, okay? the force of the gravity or the weight is balanced to the buoyancy force. And you can get that when an object is in a liquid or when it's hovering above a gas, okay? And we talk about buoyancy often when we talk about things being able to float. Buoyancy aids. You might have a life jacket, it's buoyant, okay? So this is another type of balanced force. The job that I would like you to do today is I would like you to take 2 photos in your house. One example, like the one on the left, where there is an object floating in water, where there is gravity weight going down and buoyancy force going up. And another picture where something is being balanced on a surface. So there is gravity weight of an object pushing down, but something is supporting it and pushing it back up again. Then, once you've taken those photos, you need to go onto images to mark them up, and you are going to add labels, just like these examples here. Okay, so you're going to add a label of the arrows to show the direction of the 2 forces, and you're going to write what that force is called. Okay, and when you've edited those photos, you're going to upload those onto Seesaw. You should upload both of the photos in one post. If you would like a challenge, then you could also label some examples of forces that are not balanced. So we can see that we've got the cars pushing down on the bridge and the resistance of the bridge holding the cars up. So that force is balanced because the cars are not falling down. However, the cars that are moving forward, which are being driven by the force of the engine, are also having some resistance from air resistance and friction. However, the force is unbalanced here because the car is still moving forward. So the force of the engine is stronger than of the air resistance and the friction. So in this picture, you've got an example of one balanced force, the car not falling down, but one unbalanced force where the car is moving forward. So if you would like to do an additional challenge picture with an unbalanced force, then you can do that also. I've just written a summary here of what your task is in case you are not sure. I'm going to add an extra video of how to take a picture and mark it up.